More with normal distribution. So what we're going to do now is, if we're given a z-score, we're going to find the area under the normal curve that corresponds to that z-score. Furthermore, we're going to find an x value if we're given a z-score, a mean, and a standard deviation. So that's pretty much what's about to go down. Pretty much what I just said. Right. So let's go ahead and do this. Let's find a z-score, or the z-score, that has 96.16 of the distribution's area to the right. So what we're looking for is going to look like this. We got our normal curve. We got a 0 here, 96.16 of the area to the right, right? So, something like that. It'll look something like that. So we'd like to find what the z-score is at that point. All right, well, it's going to be the opposite of the z-score at that point, right? Right, just because, you know, like, if we're one standard deviation away, we're at -1 here. And if we're one standard deviation here, we're at 1 here, right? So if we can find the z-score at this point, then the z-score that corresponds to this point is just going to be the opposite of it, right? It's going to be the negative z-score. So let's go ahead and find that. So let's find the z-score for 96.16 volts. This is how we're going to do it. We're going to use our handy-dandy calculator. So we are going to hit menu, probability, distributions, and we're going to choose inverse normal. You there? So I'll hit inverse normal. It's going to ask me what the area is. We have to express it as a decimal. So it's at 96.16. So we have to write that as 0.9616. And we're not going to change this, right? Because we're looking at it, we're looking for a z-score. We're looking for a standard value, which means that our mean is 0 and our standard deviation is 1. We hit OK, and we get so this is the z-score. This is our z-score would be 1.77. We'll round that to the 100ths place. Okay, so we'll get 1.77. And what was that? What that gave us was the z-score that corresponds to that drawing. That corresponds to this point, right? So 96.6% of the area is shaded below. But what we were looking for was this point, right? Yes. So what that point is negative 1.77. So that is actually the answer. Does that make sense, right? Because it's symmetric, and it goes negative, positive, right? And it's the same on each side. So that's why I'm able to just switch. All right, hey. let's find a z-score for which 95% of the distributions of the distribution's area lies between negative z and z. So okay, let's go ahead and draw this. So what do we got going on here? Again, we're looking at a standard normal distribution, so the mean is 0. And then we've got a point here. We don't know what it is yet. It's negative z. Over here, we've got a point here that's z. And we're looking at the shaded area in between. It says that the area here is 95%, or let's call it 0.95, right? Which means that this area here plus this area here must be 0.5, right? Since the whole area has to be 1. So that means that this area is 0.025, right? Half of 0.5. And this area is 0.025. So what I'm going to find in my calculator is going to be, let's see, what should I do? I have a number of different approaches. I just decided there might be a better way to do it. I might be doing it the long way. If I was to find the area, find the z-score, yeah, that's all I'll do. I'll find the z-score that corresponds to an area below to an area below my z that is 0.025. So I'm going to do it with the calculator, and then I'm also going to do it with the table, just to show you how to do that. So again, I'm going to use the inverse normal. So I'm going to go menu, probability, distributions, and we're going to choose inverse normal. Now our area 0.25, mean 0, standard deviation 1, because we're looking at a standard normal distribution. And I get a z-score of around negative 1.96. So what's that telling me? That's telling me that the z-score that corresponds to this point is negative 1.96, which means, what's that one then? Huh? Positive, yeah. Yeah. So those are my answers. Yay, look, I got it. Alright, so let's find the z-score that corresponds to each percentile. Okay? So we just go through this, and I didn't use the table, so I like the calculator. Picture. So I mean, if I was going to make a rough estimate of what the picture looks like, right? We're at 0. What, 10% of this? I don't know what 10% is, but it looks like that. So we're looking for that z-score. I'm just estimating what 10% of this area is. It's probably sort of. We'll go to our handy dandy calculator again. And I can just go up, copy it, hit enter, paste it, and really all I'm doing is changing this from 0.25 to 0.1 or 0.10, right? 10%, where we're always writing these as decimals. So that gives me negative 1.28. So z equals negative 1. For this one at 20, the picture would look something like, I don't know, something like that maybe. A little more. What I gotta do, let's go to my calculator, and I'll just change that to 0.2. I get negative 0.84. And now for 99, the picture looks a lot different. Because I'll be way out here, right? And I'll be looking for the score for shading all of this area. So what is Z? We'll go to our calculator again. And now instead of 0.2, I want 99.99. I get a Z-score of 2.32. All right. So here we go. You're going to have to use this formula. So if someone says, hey, if you're being asked, I don't think they're going to say hey. If you were asked for an x value, so hey, you got a z score, right? What's the x value that corresponds to that z score? You would have to use this formula. Where does this formula come from? Well, it is just a derivation of this, right? So if I took this one and I multiply both sides by sigma, right? These guys cross out. They cancel because it becomes 1. And then you have z times sigma equals x minus your mean. I add the mean to both sides, or mu. So I have z times my standard deviation plus mu equals x. That's where that thing comes from. It's just a different version of that formula that we see. Just solve it for x. Here. Alright, so let's go ahead and use this thing, alright? So, the veterinarian records the weights of Alright, the weights are normally distributed with a mean of 52 pounds and a standard deviation of 15 pounds. We're going to find the weights that correspond to the z-scores. And then we're going to interpret our results in context, okay? So, we use our formula. We're going to use this at x equals 2 times my standard deviation plus my mean. So, in this case, for the first one, for negative 2.33, we get a z-score. We'll do negative 2.33 times 15 plus 52. Which is approximately 51.4. So if we want to interpret that in context, I'd kind of like to know what percentile that's at, right? I'd like to be able to say, hey, what that means is that a dog that's 51.84 pounds, what it means is that a dog that is that heavy, it means that that dog is heavier than a certain percentage of all dogs. Okay? In order to find that, I could figure out what the z-score is. So, and let's go ahead and use our table for that. Get the table. Alright, so we'll get out the table. And I will find negative 2.33. Is that what it was? 2.33. So negative 2.33. So that's going to correspond to around 0.1%. Right, so we could say 0.99%. Let's do that. So interpreting this in context, I'll say that a dog that weighs 51.84 pounds is heavier than 0.99. So the next one, so we did that one. The next one was for a value of, so we'll call that A, let's go B. The next one was for an X or a Z value of 3.10. Figure out what that is. 3.1 times 15 plus 52, we get 98.5 pounds. So in this case, we would say that a dog that weighs 98.5 pounds heavier. Let's figure out the percentage. We'll look at the table. I'm going to look for 3.10 on my table. It is probably a fairly high percent. All the way down here, 3.10. Right there. So 99.9% heavier than 99.9% of dogs. Wow. All right, see, the last one that we were asked for was 0.58. So let's figure it out. X equals 0.58 times 15 plus 52. Or is it what we get when we do this? $60.7. So to calculate, to interpret this in context, a dog that weighs 60.7 pounds is heavier. Yeah, and let's figure out what percentage, right? What we're essentially doing is finding weight and then finding what percentile that weight is. Go to the table and find 0.58, 0.5, 8, 75.17%. No, did I get it wrong? I did. 0.58. Oh, I was at 0.6. Thank you. 0.5. 71.9. Thank you. All right. We'll empty this bucket of dum-dums yet. Grape or pina colada? Oh. It's really pineapple, but I'm calling it pina colada. All right. And I interpreted, I went a little bit further with my interpretation than that. So, here we go. Braking distances of Nissan Altimas, normally distributed with a mean of 129 feet and a standard deviation of 518 feet. What's the longest braking distance one of these Nissan Altimas could have? It'd still be in the bottom 1%. So essentially, what they're asking for is a z-score that corresponds to that area. Okay, so first we need to go to our calculator. And right, we'll use inverse norm, but instead of 99%, we're going to go opposite, we're going to go 0.01%, right? We get negative 2.32, 3.33. Hey, I just wanted to go ahead and show you how to find that. If your calculator broke, you had to find it old school style. Okay. What you would do is you would go inside of this table and try to find the value that's closest to 0.01. Okay? The value that's closest to 0.01. So those are all much larger, right? 50% at the top. Right? And as we go through this, as we go up on this table, our values get, oh, that's actually the one. Our values get smaller and smaller. So the closest one that we find, I might have accidentally saved it with this, sorry, not letting me erase it, is this one, right? That's the closest value that we can see on the inside to 2.01. And we'll see that that is at negative 0.233. Which corresponds to our calculator value. So you can do this using the table if you like. I think the calculator is a little quicker. So that's the first step. We found out that our z value is going to be negative 0.233. Now we got to figure out the x value. So we're going to use that formula that tells us, right, that x is equal to our standard deviation times our z-score plus our mean. So in this case, that's going to be 5.18 times negative 2.33. I know I reversed them from the way I was doing it before, but it still doesn't work. I put that in my calculator. 5.18 negative 2.33 plus 1.9 is approximately 116.93 feet, right? And so that's the longest braking distance one of these Nissans can have and still be in the bottom numbers. I wonder how fast it is. Because that's a lot of distance. Yeah. I would hope I wasn't walking. I needed to stop very quickly because all right. Cool. Oh, we have another one. All right. Lengths of time people have worked at a corporation are normally distributed with a mean of 11.2 years and a standard deviation of 2.1 years. The company decides to fire a lot of people, and they're like, "Hey, we'll just fire the new guys." As a matter of fact, just the lowest 10% of people that have been here, right? According to how long they've worked here. So how long do you have to work there to not get fired? So first thing you need to do is we need to find a z-score that corresponds to 0.10. So we go to our we're going to get to the calculator. It's much quicker. All I gotta do is change this to 0.1. Same thing as 0.10, right? Now I get negative 1.28. So now I can solve x equals my standard deviation times my z-score plus my mean, 11.2. Figure out who's getting fired today. Plus 11.2. So, anyone who has worked here, less than 8.5 years, 8.512 years, getting fired. Sorry. We put your time in. Okay, so, sorry. All right. So, this is what we did. Yay! Here is her assignment. I don't necessarily need you to sketch all of these. Some of them it's helpful to see. It asks you to find Z, so you're already. There it is.